In Lesson 2, we will show you how to use 2 QikEasy IR Seekers for Spike Prime to detect a RoboCup Soccer IR Ball with full 360-degree coverage. If you have not completed Lesson 1, please make sure you do so before you continue with this lesson. To set up the hardware, we start by following the procedure we learned in Lesson 1 to set up the first IR Seeker board on top of the QikEasy expander. Note that this first IR Seeker board is responsible for sensing the IR ball when it is in front of your robot. There are 2 ways to set up the second IR Seeker board. For the first way, we simply stack another IR Seeker board on top. Make sure this second board is pointing in the opposite direction as the first one. For the second way, we will use the provided cable to connect the first and the second IR Seeker board. The cable provides extra flexibility on how these sensors are placed on your robot. With 2 IR Seekers attached, they work independently of each other. Each sensor returns the direction value with 9 units of precision in exactly the same way as described in Lesson 1. Because the IR Seekers are attached to one single QikEasy expander, these sensors will only take up one port on the Spike Prime hub. The direction and signal values will be returned as 4 different color sensor measurements as illustrated. Let's start doing some programming. Firstly, we want to design a generic function block to combine the 2 IR Seeker data sets into one. For the direction value, we will merge the 2 individual values ranging from 1 to 9 to become a single value ranging from 1 to 18. For the merged signal strength, it is simply take the higher of the 2 signal strength values onto our word block program in Spike app. We will start by creating the 2 global variables, direction and signal strength. In our main program, we first initialize direction to the default value of 0. Note that 0 has a special meaning that no IR signal is detected. We will also give it a forever loop for reading our IR sensor data continuously. Now, we will create our generic function block to read data from the 2 IR Seekers. The function will combine the data together and save the combined values into the 2 global variables. Let's call this block IR Read 360 Sensor Data. Similar to what we did in Lesson 1, we will pass the port number and the reduction factor into this block. We will create another function block as a helper for converting the 4 sensor data values into the 2 variables. This block will be directly called by our IR Read 360 Sensor Data block. Let's call the block IR Combine 360 Sensor Data. This block will take the 4 sensor data values from both the front and the back IR Seekers as parameters. Now, in our original IR Read 360 Sensor Data block, we will call IR Combine 360 Sensor Data with color sensor data values collected from our Spike Prime port. Make sure that the channel parameter is used to read the reflection value and the RGB values. As noted in our previous lesson, reflected light value should always be divided by 4, and RGB values are to be divided by the reduction factor, which is either 4 or 1 depending on your Spike app version. In the IR Combine 360 Sensor Data block, we first check to make sure at least one of the IR Seekers is able to receive any IR signal. If not, we set the direction variable to 0. For the normal case, we check to see if the front IR Seeker or the back IR Seeker has sent stronger signal. If the front side is stronger, we will set the direction and signal strength variables to the data values from the front sensor. We round the sensor data values so that the variables are set as integers. If the back side is stronger, we set the global variables to the data values from the back sensor. To return a unified 360-degree direction value, we will need to shift the direction to the back half of the 1 to 18 range by adding 9 to the value. To complete our program, we will call IR Read 360 Sensor Data in the forever loop specifying that the sensors are on port C, and we pass in a reduction factor of 4 because we use Spike app 3 here. If you are using Spike app 2, you should pass in a 1 instead of 4. Let's test our program. Connect the app to your hub and run the program. With the ball going around the sensors, observe how the direction variable changes between 1 and 18, and the signal strength variable ranges between 1 and 256. For those of you who uses Python, here's the program in Spike app 3 with the exact same logic. Instead of displaying the direction inside the Spike app, we want to visualize it on the spike hub. The idea is to display the direction on the spike hub using the LED pixels on the outside rim of the 5x5 matrix. With direction values ranging from 1 to 18, we need to map each possible value to a LED pixel. For instance, direction 1 will be mapped to the middle pixel on the left side. Direction 2 will be mapped to the pixel above it. And direction 3 will be mapped to the pixel at the upper left corner. Following this pattern, we can create a table that maps all the direction values to the XY values of the corresponding mapped pixels. To use this mapping table in our word block program, we first convert the XY values to a string. Using this string, we will have a function block that draws the LED pixel based on an input direction value. In our main program, we will first initialize the LED matrix. We will draw a cross in the middle to give our direction pointer a frame of reference. We will create some new variables. Direction to XY map is used to store our mapping string, which was shown in the previous diagram. Make sure we'll initialize direction to XY map with the string value that we previously calculated. We will also create the variables for the X and Y coordinates of the current pixel being drawn. Now let's create our draw pixel function block. The block takes the direction provided by IR Seeker as input. In the block, we will first turn off the previously drawn pixel as recorded by the X and Y variables. If the direction parameter value is non-zero, we will calculate X and Y by extracting the coordinate values from the direction to XY map string. We use the letter block to perform this extraction. The explanation for the formula used to calculate the indices is left as an exercise for the audience to explore on their own. Note that the formula uses a multiplier of 3, because 3 is the length of the substring, which represents a pixel. In the main forever loop, we will call draw LED pixel on every loop iteration. To reduce the flickering, we will add a wait block to give each iteration a bit more time to light up the pixel. And to prevent our call to set pixel from crashing, we must initialize X and Y with valid values. And this completes our changes. Now, let's do some testing. As we slowly move the IR ball around the IR Seeker stack, observe how precisely and reliably the light pixel moves according to the location of the IR ball. This is the power of QikEasy IR Seeker. For those of you who uses Python, here's the program in SpikeUp 3 with the exact same logic. In summary, we have learned how to use two QikEasy IR Seekers to detect the location of the IR ball with 360-degree coverage. We implemented a function to retrieve and calculate the combined direction and signal strength values using word block and Python. We also learned how to visualize the direction value with SpikeHub's LED light matrix. Based on the examples we provided, you should now be able to incorporate the capabilities of QikEasy IR Seeker into your Spike Prime robots programming logic, and be ready to participate in the RoboCup soccer games with a competitive edge.